Let un be a sequence. Here we assume that u2n is convergent and u2n plus 1 is also convergent. The question that we have to answer is u sub n convergent? Okay, so this is a nice question that will help us deal with sequences in a different manner. Okay, so what we know is un is a sequence, okay, but we have only u sub 2n and u sub 2n plus 1 are convergent, and we want to find if un is convergent. When we have questions like this, if this statement is true, we have to prove it. If it's not, we have to find an example where we can show that this is not the case. That means it's not convergent. So we are looking to answer the question, is un convergent? So we can find some simple examples where un, let's take un is minus 1 to the power n. Okay, this one is not convergent, okay, because it keeps going up and down between 1 and minus 1, and therefore it doesn't have a limit, because we know that if a sequence has a limit, that limit must be unique. Okay, here u2n is minus 1 to the power 2n, so here we know that this is just 1. There's minus 1, so this is minus 1 raised to 2 and raised to n, which is 1 raised to n, which is 1. Okay, u2n plus 1 is minus 1 to the power 2n plus 1. So here it's minus 1 times minus 1 to the power 2n, which is minus 1. As we see here, this sequence is always constant. It's equal to 1. So for all the even numbers, u2n is 1. So it's a constant, and therefore it's convergent to 1. u2n plus 1 is a constant as well, and it's minus 1. And for all the odd values of n, it's minus 1, and it's convergent to minus 1. So here we see that we found two sequences, u2n, which is convergent, and u2n plus 1, which is convergent, but un is divergent. Okay, so it doesn't have a limit. It has these two values, 1 and minus 1. Okay, and this answer the question is that, is un convergent? No. Okay, so we found the sequence that we need. Okay, we can find another sequence based on the cosine of n. We can construct this n in such a manner that this one will be 1 or minus 1, okay, depending on the values of n. Okay, we can construct this one in such a manner, and the same thing here, we can get the even and odd values. So anyways, so if we have a sequence such that eu2n is convergent, eu2n plus 1 is convergent, it doesn't mean that un is convergent. Okay, now the question that we need to answer or to ask is when we have un convergent, is u2n and u2n plus 1 convergent? Yes. So we have one way, but we don't have the other. Okay, and this answers our question. We're going to come back to this question. When we have un convergent, it means that u2n is convergent and u2n plus 1 is convergent as well. Okay, so we're going to prove that, and later we're gonna get some other conditions to make this one work. Okay, so here if we say that, or we can make it in such a manner that this one will get us to this limit, we can say if un is convergent to some L and u to n, or u to n plus 1 is convergent to some L, and u to n is convergent to the same L, then un is convergent. Okay, we can prove this one using the definition here of the limit of the sequence. Okay, anyways, we did answer the question and we added more.